This video is a continuation for lesson 7.7, which is on applications of rational equations. And in these examples, which we're going to look at 3 of them, they all focus on rate of work. So for the example, number 18 out of the textbook, it says, by himself, Chris can mow his lawn in 60 minutes. If his daughter Claudia helps, they can mow the lawn together in 40 minutes. How long would it take Claudia to mow the lawn by herself? So this is going to use our rate of work formula. So the rate of work for 2 workers is 1 over t sub 1 plus 1 over t sub 2 equals 1 over t, where t is some unit of time. And make sure that whatever that unit is, that it's consistent all the way across. So in this problem, we're dealing with minutes. It's all set up to where everything's in minutes, which is great. So every single one of these have to be in that same measure of time. Now, t sub 1 is just the measure of the time that the first worker would take. T sub 2 is the time that the second person would take, and then t is the total amount of time that they take together. So now that we have the formula wrote out, we just need to plug in the information that the problem tells us. So the work rate of the first worker, or the time that the first worker takes, Chris himself, was 60 minutes. So we're going to have 1 over 60 plus 1 over, we don't know the amount of time that Claudia takes by herself. That's what we're trying to solve. So we can go ahead and let C represent Claudia. And then the amount of time that they take together would be less than what Chris does by himself. So it makes sense that this is going to be 1 over 40. So it takes them 40 minutes. So now we're going to go through, just like before, with all the questions on rational equations, just like we practiced in lesson 7.6. To solve this, we're going to find the least common denominator between all 3 of these denominators. And that least common denominator is going to be 120c. So I'm going to multiply every single part of this equation by our least common denominator. And when I do that, there's going to be parts that cross cancel. So the 1 over 60 times 120c is going to leave me with just 2c. The 1 over c times 120 over c, just 120c is going to be just 120. And then the 140th times 120 over c is going to leave me with 3c. And then I solve this by subtracting 2c from both sides, and we would have 120 equal to c. So 120 minutes is the amount of time that Claudia would take by herself. Our next example is going to use the same formula. So with this one, it says, together, Sari and Riley can both mark the lines on the soccer field 18 minutes faster than if Riley lines the field on her own. If it takes Sari 56 minutes to line the fields by herself, how long would it take Riley to do the job alone? So again, we're doing this rate of work type of question, and it's only of 2 workers, so same formula as last time, 1 over t sub 1 plus 1 over t sub 2 equals 1 over t, and again, t is a unit of time. And again, we need to make sure that we're consistent with whatever that unit is. So if it's all minutes, make sure it's all minutes, seconds, hours, everything's going to be the same measure. So when we go to set up this problem, again, t sub 1's the work rate of the first person. So it tells us that Sari can do the job in 56 minutes by herself. So we know this first one's going to be 1 over 56. We're trying to figure out how much it would take, or how long it would take for Riley to do the job alone. So we don't know the t sub 2 value. So we can let r be Riley. So 1 over r. And then the time together, it's just that they can do it 18 minutes faster than if Riley lines the field on her own. So this is actually going to be 1 over r minus 18, since it's 18 minutes faster than whatever Riley does. And now we need to go through and solve this rational equation by finding the least common denominator and then multiplying the entire equation by that least common denominator. So the least common denominator in this case is actually every single one of these multiplied together. So we're going to be multiplying both sides of the equation by 56r times r minus 18. So that is the least common denominator, and that's going to allow us to cancel out all of these denominators and have a much easier equation to work with. So once we do this, certain parts are going to cancel out. So this 156 and this least common denominator, the 56s, are going to cancel out. So you're left with r times r minus 18. The 1 over r is going to cancel out with the r in this one. So you're left with just 56 multiplied by r minus 18. And on the right-hand side, the r minus 18s will cancel out, and you're left with 56r. Then we just need to go through and solve this. So again, distribution, we're going to have to do twice in this question. So r times r is r squared minus 18r. Then doing the distribution over here, we'll have 56r, and then 56 times the minus 18 is going to give me minus 1008. And again, this equals 56r. Now, we do need to get this in standard form since this is a quadratic. So to solve a quadratic, it needs to be in standard form so that you can FOIL it, or not FOIL, excuse me, factor it. And so we're going to subtract 56r from both sides to start. And the reason I'm doing that first is because this is going to end up canceling out. And so our trinomial, our quadratic here, it's going to be r squared minus 18r minus 1008 equal to 0. And then this is where we need to factor. So with factoring this, again, we can use our method that we've talked about before that helps us kind of organize our thinking. This is a nice one. We don't have to do the AC method because we just have our C value. And if you did do the AC method, it's just 1 times C. So it's just going to be this negative 1008 on the top, which again, we're trying to multiply to get to. Then also add to get to this middle term, negative 18. That combination that we're looking for that multiplies to a negative means that we're going to be looking for a positive and a negative number. And those numbers end up being positive 24 times negative 42. So this quadratic breaks down into r plus 24 multiplied by r minus 42 equal to 0. And then these are our two equations that we're going to end up solving. So we're going to have r plus 24 equal to 0. We're also going to have r minus 42 equal to 0. And then solving each of these, we would subtract 24. You'd get r is equal to negative 24 minutes. Or we get r equal to 42 minutes. Now, just like before with these quadratics, sometimes an answer doesn't make sense. It doesn't make sense to do it in negative 24 minutes. So this is actually an extraneous solution. It's not valid for this problem. So the amount of time that Riley would take would be 42 minutes, and that makes sense for the situation. The last example for this video is actually about leaking, and so the formula for this is going to be a little bit different. But let's take a look at the problem. So this is question number 22, and it says a leak in the hull will fill a boat's bilge in 8 hours. The boat's bilge pump can empty a full bilge in 3 hours. How long will it take the pump to empty a full bilge if the boat is leaking? So as I mentioned when we first started this question, the formula is going to be a little bit different than the other rate of work questions. And the reason is because we have two actions that are opposing each other. So instead of saying just plus 1 over t squared, they're not working together, they're working against each other. So this needs to be a negative. So with this question, our situation is that we have a pump that's trying to empty it, and then the boat is also filling with this leak. And so we are going to look at this positive value as the pump, which can empty it every 3 hours. So we got 1 over 3. But then this leak fills it every 8 hours. So we're going to have negative 1 over 8. And then that equals 1 over t. So we're trying to figure out the amount of time that it's going to take this pump to empty this full part of the boat if it's leaking. So the least common denominator in this case between all three of these denominators is going to be 24t. So we're going to multiply everything by 24t. And again, what's nice when we do that is that the denominators are going to end up canceling out, and we're left with an equation that looks a lot nicer to work with. So the 1/3 and the 24t, once you multiply those together, you're going to be left with 8t. Plus, then we're going to have a negative 1/8 times the 24t, so you're going to have negative 3t. And then on the right-hand side, the t's will cancel out, and we're left with 24. Combining like terms, this will be 5t equal to 24, and then we just need to divide by 5. And once we divide by 5, we find that the time that it would take to empty this full part of the boat if it's leaking is going to be 4.8 hours. And that's how we would solve that question.